So we have a set of data here, which is how quickly various divisions of our company are able to promote frontline managers. And we're going to describe the data with the three most prominent measures of central tendency and dispersion. So the first measure of central tendency we're going to discuss is the mean. And the mean is also called the average of a data set. And it's not the middle value of the data, it's the value that balances an entire distribution of numbers. So the mean is the sum of a set of scores divided by the number of scores summed. So to do that, we're going to add each of these numbers.
So we're going to do 18 plus 17 plus 11 plus 23 plus 1.
And we're going to divide that by 5 because we have 1, 2, 3, 4, 5 numbers. So 18 plus 17 plus 11 plus 23 plus 1 is 70. And 70 divided by 5 is 14. So the mean of this data is 14. So also important is that the formula for the population mean is symbolized by this, which is mu, and it equals sigma of x, which is the sum of each score in a data set divided by the number of scores in that population. And the sample mean formula is symbolized with a capital M equals the sum of each data score divided by the sample number. So next we have the median, which is the middle value in a distribution, and the median value represents the midpoint, where half of the scores in the distribution are going to fall above the midpoint and half are going to fall below. So to calculate median, there's a formula where we find the position, which is where the number is going to fall. So the formula for that is going to be n plus 1 divided by 2. So for this example in particular, n is going to be 5 because there's 5 numbers in our data set. So this is going to equal 5 plus 1 divided by 2. 5 plus 1 is 6, divided by 2 is 3. So another note is that before you calculate the median position, you have to order your data in numeric order. So this is how the data was given to us, starting with 18, 17, 11, 23, and 1, but I reordered it so it would go in order 1, 11, 17, 18, and 23. So after calculating our median position, now we just count. So 1, 2, 3. This means that 17 is going to be our middle value. The median is a really good measure of central tendency when you have extreme outliers, because if we just use the mean like we just did for a data set with outliers, then it's going to affect the mean and it's not going to be as accurate. But if we use the median for that, the median position is not going to change no matter what outliers there are. So the median could be more informative to describe data in a distribution with one or more outliers. So the last measure of central tendency is the mode, and the mode is simply the score that occurs most often in a data set. So in this data set, all these numbers only occur once. None of these numbers occurs more than once. So there is no mode for this particular set of data. So out of these three measures of central tendency, for this particular data set, I would say the mean is going to be the best measure to describe this data. The mean is usually preferred as the best measure of central tendency because all the values in the data set are going to affect the mean in the calculation. Any new scores are going to affect the mean. And I would use the median to describe a data set only when there are outliers, because extreme outliers are going to affect the mean. And for mode, I would not use this solely to describe any data sets. I would just report the mode along with the median and the mean. In this data set, there is no mode, there are no outliers, so the mean is going to be the best measure to describe this data set. So now with the same data set, we're going to move on to measures of dispersion. And measures of dispersion is a way to measure the dispersion or the spread of scores around the mean. And the variability of scores can never be negative, so it's always going to be from 0 to positive infinity. The first measure of dispersion that we're going to discuss is range, and this is the simplest way to describe how dispersed scores are. And in order to find the range in a data set, it's simply going to be the largest value minus the smallest value. So in this case with our data set, the largest value is 23. And we're going to subtract that by the smallest value, which is 1. And that's going to be 22. So our range for this data set is 22. So the next measure of dispersion we're going to discuss is variance. And variance is going to be the preferred estimate of variability because it includes all scores to estimate variability. Variance is a measure of how far a set of data is spread out. So that's the measure of how far each number in the set is from the mean and from every other number in that set of data. And the value of the variance can be 0, which means there is no variability, or greater than 0, which means there is variability. So for variance, there's two parts, the population variance and the sample variance. We're going to start with the population variance, and the formula for that is going to be lowercase sigma squared equals the sum of each score subtracted by the population mean squared, and we're going to divide that by the population size. So again, this symbol mu, which we did for the mean in the previous page, is the population mean, and uppercase N is going to be the population size. So in order to calculate the population variance, if this was the population that we're measuring in our example here, we're going to start by finding the mean, which we did in the previous page, which we already found was 14. So next in our formula, we're going to take the sum of each score subtracted by the population mean, which we found, squared. So to start off, this is our data set, the same as up here. So we're going to start off with the first score in our data set, which is 1. We're going to do 1 minus the population mean, which is 14. And then we're going to square that. Then we're going to continue with each score in the data set. So we're going to do 11 minus the population mean, 14 squared. And we're going to continue with the rest of the 3 numbers in the data set. Well, what I did here was I just finished the numerator. So like it says in the formula, we're going to take each score in the set of data, we're going to subtract that by the population mean, and then square each one. Also, the x minus mu here in the formula is a deviation. So this is going to be the difference of each score from its mean. So now, using a calculator, I just calculated each one of these. So 1 minus 14 squared is 169, 11 minus 14 squared is 9. 17 minus 14 squared is 9, 18 minus 14 squared is 16, and 23 minus 14 squared is 81. Now we're going to add up each of these numbers, so to get the sum here. So 169 plus 9 plus 9 plus 16 plus 81 is 284. And we're going to divide that by the population size, which is 5. 284 divided by 5 is going to give us 56.8. So we can say that the population variance for this data set is 56.8. So really quickly here, the next formula we have is for sample variance, because we just calculated population variance, and sample variance is going to be S squared equals the sum again of each score subtracted by the sample mean, which we also did in the previous page, squared, minus the sample size minus 1. So to calculate sample variance, you would pretty much follow the same steps as up here, except you would be using the sample mean from your data set, and the denominator is going to be your sample size subtracted by 1. But it's going to follow the same steps. You're going to take each score, you're going to subtract it by your sample mean, square it, sum each of those, and then you're going to divide it by your sample size minus 1, and that's going to give you your sample variance. So the last measure of dispersion we're going to talk about is standard deviation, and the standard deviation is pretty much a measure for the average distance that scores deviate from their mean, and that's going to be measured as the number of standard deviations that each of those scores deviates from the mean. And in order to find the standard deviation, it's just going to be our population variance or sample variance squared. So our population standard deviation can be written as just SD. It's going to be the lowercase sigma symbol equals the square root of variance. And as we just did previously, variance is lowercase sigma squared, as you can see here. So it's just going to be the square root of that. So to find our standard deviation for our data set, we're going to do the square root of our population variance, and as we calculated before, our population variance equals 56.8, and the square root of 56.8 is going to give us 7.5365. We're just going to round that to 7.5. So our population standard deviation for our data set is 7.5. And just as variance has population variance and sample variance, respectively, we have a sample standard deviation. So the formula for that is just going to be that lowercase s equals sample variance squared. As we did before, this is the formula for sample variance, so that sample variance is going to be squared. So after looking at each of the three measures of dispersion, I'm going to say that standard deviation is going to be the most useful. It gives us more clarity because it looks at how spread out our group of numbers is from the mean by taking the square root of the variance. And the variance is just going to measure the average from which each point differs from the mean. And also the standard deviation is more useful for interpretation because the standard deviation is going to be in the same scale as the original data as opposed to variance. So I would argue that standard deviation is most useful for interpretation of data.